So theoretically, we are saying that attitudes are different from intention, right? And then we have to test this empirically as well, right? We have collected the data, and then we have checked through this software by this is a test, discriminant validity, right? And there are three ways to see that these attitude is different from intention or not, right?
Yeah.
So when we build a model, obviously theoretically we say that attitude is different from intention, but we have to see that empirically as well, because maybe respondent or responses that the way you have collected the data uh, maybe raises some question the way you have collected the data from the respondent. Maybe your respondent are not understanding your items, right? They have responded in such a way that empirically it is very difficult or uh, not possible to distinguish between those two variables.
Yeah.
So discriminant validity tell us that your variables are this different. They are not measuring the same construct, right?
Yeah.
If
Yes.
we are unable to establish discriminant validity, we have to delete one variable,
Yeah.
right? We cannot keep two similar variables, right?
Yes.
So that's what the purpose of discriminant validity.
Yeah.
Internal consistency is because when we measure variable in a reflective way, the items are very close to each other, right?
Mm.
The timeliness, I've shown you the timeliness, a variable timeliness, and we have seen the item x1, x2, x3. These three items are very close to each other. So the response should be consistent, right? So we cannot say that with if you're measuring the items reflectively and respondent is responding strongly agree to the one item and is the next item is saying I'm strongly disagree, right? Because items are reflective and they are measuring the same attributes. They are very close to each other. So the response should be close as well,
Mm.
right? That's why when we punch the data, we see that you should see the questionnaire, right? If you see a trend, if you see a person ticking on neutral, 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 the data is useful. If a person is um, marking strongly agree on one item and strongly disagree on second and again strongly agree on third and strongly disagree, so there is a pattern in the data that the respondent has not read the item, right? So that's why he's you can see a pattern in your question. That data is useless as well. So data should be internally consistent. The response should be consistent. How we measure it through alpha, CR, or Hensler rho, right? So indicator reliability is to what extent indicator is loading on to the construct, right? So these are bit technical terms, but
Yeah.
you have to,
Since yeah, since they are very new in the research field in MS1, so they are yet to know about the discriminant validity and the convergent validity. You
so you
explained very
have
well,
to,
doctor.
yeah, you have to read
Yes.
little bit about these things.
Yeah. Yeah.
A lot of
That's
literature is available. I'll
yeah.
be sharing the two books as well.
Yeah, that's
Okay.
what wonderful you said in initially that actually you will be providing two books which are very beneficial for the rest of the participants, that how would they come to know about the different terminologies, what are the different concepts. Once you come to know about these things practically, then you can learn the concept later on from the book which we will be providing you. So thank you very much. Yes, please go ahead.
Okay. When we see outer loadings, the criteria for the outer loading is this. If we get a loading value less than 0.40, we have to delete that item,
Mm.
right? If the outer loading is greater than zero point 0.5 and less than zero point 0.7, then we have to see that if we delete the item, to what extent we can improve AVE,
Yeah.
right? So if we are deleting an item whose outer loading is greater than 0.40, and why we can improve our average variance expected or AVE, still we can delete the item. If our AVE criteria is met already, then we don't need to delete any item whose outer loading is like 0.50, 0.60, right? So if it's greater than 0.70, we have to retain it. So if it's less than 0.4, delete. If in the middle, then we have to see our AVE as well, because AVE is calculated through outer loadings, right? So these two are related with each other. So we have to met the criteria of AVE as well. So at times we have like 5 items and 2 or 3 items have loading less than 0.70, then it is very difficult to get AVE greater than zero point 0.5. The cutoff for the AVE is should be greater than zero point 0.5. So then we see that which item we should delete. I'll be doing that as well. Which item should we delete? We delete one item and then we run algorithm again and we see AVE has improved or not. So we repeat this process, but remember, we cannot delete more than 20% of the items, right? For example, if you have 10 items, you can delete only 2 items, right? If you have five and if you delete 3 items from 5 items, then you are left with what the construct you was making. You have lost more than 50% of the information, because the data you are getting from the people is the information. So if you're deleting that the items, it means you are deleting a certain information. So you cannot delete more than 20% of your items, right? So that's another problem. If your data is not quality data, you have to delete lot of items. Then the literature say you cannot delete more than 20%. So
Yeah,
again, if you have deleted more than 20%, that means the construct you're measuring is not that construct now, because
yeah,
the 5 item was used to measure that construct. You have deleted 3 already. So what is
yes.
left? You have
What?
deleted 60% of your information.
Yeah,
The 2 items are not measuring that construct. So you
yes.
have to be very careful when you collect the data,
Yeah,
because this system will show
not
you
allowing.
everything.
Yeah,
You
as
cannot.
the here at all also said that if you have less than three items, you cannot run the analysis.
Yes.
Yes,
So you have.
wonderful.
That's what I'm saying. Collecting primary data is a very difficult task. You have to be very careful when you collect primary data. All the
Yes,
protocols, like I haven't discussed, like pilot testing, pre-testing,
yes.
construct validity, content validity, their whole process of testing a questionnaire before you go for full-scale data
Yeah,
collection.
we can have
That was a,
another webinar on it, that how to
yeah,
yeah,
yes,
do the
yes.
questionnaire analysis
Because
properly.
today we've just focusing on analysis, but
Yes,
that's another full length of session that
yeah.
what the
We will definitely
issues that.
arrange one workshop on it, that how to
Yeah.
develop a questionnaire properly, what things needs to be considered in terms of content validity, face validity, and the discriminant and the conversion validity. All right, sir.
Okay.
Yeah,
So, okay, we have seen the item loading. The cutoff for the item loading is it should be greater than 0.7, right? Okay. The next is we can see alpha, rho, CR, AVE, right? The cutoff for all these three, alpha, rho, CR is should be greater than 0 0.7, right? And average various extracted should be greater than 0.5.
mm,
Uh, this software gives you graph as well, graph in a graphical form as well. So you can quickly see the cutoff is zero point 0.7 and all the values are above the cutoff. So it's very easily you can see on this software. If you don't like numbers, you can see through graph as well. For discriminant validity, we have mentioned three criterias. We use HTMT. For HTMT, cutoff is it should be less than 0.85 or 0.90. So we have references that tell us about this cutoff point. This is how we can calculate AVE manually as well. AV is we get the loading values. If we square the loadings and then we add for one construct. For example, we have construct which have three items, like 1, 2, 3. We have loading for three items. We can square those loadings, right? And then we can add them and then take an average of those loading. That's why we call it average variance extracted, right? This is the average of square of item loadings. So we can calculate it manually as well. This is how we report. Uh, in research articles or thesis, this is how we report. We mention the construct, then we mention the items of that construct, item loadings, AVE, CR. Loading is for each item, AVE is for the whole construct. So for one variable or construct, we'll see one value of AVE and CR. This is for the variable. The loading is for each and every items. This is how we report in thesis. These are the cutoffs. I've already told you AVE should be greater than 0.5. HTMT should be 0.85, 0.90. Internal consistency, composite reliability should be greater than 0.7. Indicator loading should be greater than 0.708. So these are the threshold given in literature. So you have to mention those and then compare your data to what extent your data meet these cutoffs. If all these things have been done or correct, only then you can move towards your structure models, right? So whatever we have seen in previous slide that were related to the measurement. Now we're moving toward structure model. From structure, we mean, so can you see the model? When we build the model, you will see the yellow and blue ones. The blue ones are the construct, the yellow are the items or the question that was in questionnaire, right? This is how we build a model in SMARTPLS. We can hide the items and then we can see only the construct. So this is the structure model. So the measurement model shows the relationship between items and construct, right? So we have seen that. The next step is structure model. The structure is what you what was your hypothesis, right? The variable link with each other, A into B, B into C, mediator, moderator. So this all is what we call a structural models. The relationship between the construct variables is called structural model. So we test basically five things in structural model, right? The first thing is we'll check the collinearity. The second, we check the significance and relevance of structure model. The third is level of R square. Four is effect sizes. The fifth is assessment of predictive relevance Q square. And the sixth is small Q square effect size. So these are the six steps that we perform in structure model. We have to report all these values. The first thing is uh, collinearity. Okay, what we mean from collinearity. For example, we have a model like y is equal to a plus bx1 plus cx2, right? So our independent variable should not be highly correlated. This is one of the assumption of OLS regression, right? That our IVs should not be highly correlated with each other. Means x1 and x2 should not be correlated with each other. If they are correlated, it means there is a multicollinearity within your model, right? What it does is it makes your coefficient inefficient, right? How we measure it? We measure it through VIF, variance inflation factor, right? And um, uh, VIF is calculated for each and every independent variable. For example, if we have a model like y is equal to a plus bx plus b2z plus b3a, right? So we have three independent variables x, z, and a. So we have to calculate VIF for each independent variable. The cutoff for VIF is it should be less than 3.3. That's the most strict criteria. Some of the literature says should be less than 5. Even we have a literature that says should be less than 10. So, uh, but 3.3 is the most strict criteria. So it's up to you which one. You have a different literature available, so it's up to you which one you want to
Perfect.
use for your analysis or prefer for your analysis, right?
Yeah.
We can calculate it manually as well. The system will give you VIF values. You don't need to calculate it manually, but we can calculate it manually as well.
Yeah. True.
So uh, the VIF value is also in algorithm, right? I just told you we run the all algorithm and we can find the VIF values. Don't need to calculate many. Just you have to click on collinearity statistic VIF. In quality criteria, you get an option, you click, and you have to click on inner VIF values, right? So you can see all the values are within the probably you are greater than 3.3, but still you have a literature which says it should be less than 5 or 10. So there's no issue of collinearity in this model. Okay, the next is sixth step. First step was collinearity, right? Second is assessing the significant relevance of structure model. This is what you was looking for. You have built a model, you have certain hypotheses, you want to test those hypotheses, but this is how we reach to this point, right? So you have done all the things, measurement model, etc., etc. You have checked VIF, collinearity, and then you can test your model, right? That whether your hypothesis will be accepted or not. We go to calculate option and we run bootstrapping. Firstly, we have run PLS algorithm, right? So up till now, whatever we have obtained through algorithm, right? Now we have run PLS. We have gone to calculate and then we have selected bootstrapping, right? So after selecting bootstrapping and running it, we'll get this relationship, whatever you have in your model. So we see p-values. P-value should be less than 0.05. So that's where we say that our relationship is significant. This is how we check our relationships. The third is assessment of R-square. R-square tell us what extent our all IVs explain the variance in DV, right? We build a model, we have certain independent variables, and we have a DV. What we were looking for is that to what extent our independent variables bring a variation in our DV, right? So how we can check? We can check through R square, right? So the value of R square ranges from 0 to 1. 0 means no explanatory power. We also call R square a coefficient of determination, right? 0 means your IVs are not explaining any variation in your DV, means IVs are not related at all to your DV, right? So it's a misspecified model. The model doesn't exist. One means there's a perfect explanation, which is almost impossible because we cannot find a model which can explain a DV 100%. One means your IVs are explaining the 100% variation in your DV. Obviously, this is
STEM. Yeah.
highly unlikely that we get such sort of results. So your R scale will range between 0 to 1, right?
I see, but
So we have different literature which says we have
man,
Cohen 1998, we have Chen 1998, we have Hare et al 2017. So there are different cutoffs that explain that whether your IVs are have a moderate explanation or they have a week or whatever. So different literatures available. You can quote, it's up to the latest is here at all. It says that if you have a R square of 0.75 or greater, it means that there is a substantial explanation of your IVs, of your DV through IVs. Or if it's zero point 0.5, it's moderate. If it's 0.25, it's weak, right? So you can have different options available here, but the latest one is here at all. R square, we have to go to the results of algorithm, and then we can see an option of R square. We click on R square, we get the values. You can see the values 0.63, 0.29, whatever, right? So we can explain it as we have discussed already. The next is assess the level of effect size. This is very important. R square tell us the combined effect of IVs on DV.
Yeah.
The effect size tell us the effect of each and individual independent variable, right?
Yes.
R square tell us together,
Yeah.
my 3 IVs, my 4 IVs explains this much of variance in DV, right?
Yeah.
If we want to see which one IV is more, if having more effect on DV, how we can see through effect size, right?
Yes.
Effect size will be reported for each and every IVs.
Mm.
From here, we can see that which of my variable is more uh, related or explaining more variance in DV. This
Yeah.
has implication for the industry, or whatever the research is being applied, or if you're doing for certain industries, you can suggest this is the variable which is more effective, so the management should focus on these variables. So effect size is important in this aspects. It will
Yeah.
tell us individually which variable is more effective, or explaining more variance, which variable have a weak
Higher impact.
relationship.
Yes.
Yeah, so we'll check through algorithm. In algorithm, we get the option of F square, so we can click on that. We can see that to what extent our IVs have effect on DV, right?
Mm.
The next is predictive relevance Q square. So we run another uh, option in, we go to calculate and we see an option of blindfolding, right? So this is the third procedure. The first one was PLL algorithm. The second one was bootstrapping. The third is blindfolding, right? When you click on blindfolding, we get result of Q square. Q square. If the value of Q square is greater than 0, it means that your model have predictive relevance, right? So these are the steps we done in structural model. So I am quickly gonna go to uh, mediation and moderation, and then I'll run all those in smart PLS, right? So mediation is basically sometimes our IVs and DVs, the relationship between IV and DV is not explained properly, right? So to explain the mechanism that is involved between I and DV, we sometimes bring in a mediator. So when you have a mediator, when you want to introduce mediator within your model, you need to have a justification, right? Normally, if IV and DV have a consistently strong relationship in previous literature, this is one of the justification that we use. That if IV and DV are consistently strongly related in literature, that means there's any other variable intervening between that relationship. But obviously, you need to have a justification for inclusion of mediator within the model. There was one example I can discuss how a mediator works. So I'll share this slide. You can go through these. Mm, uh, there was very famous approach being used to check the mediation. Barron and Kenny, 1986,
Yeah.
right? This was a very famous paper, cited thousands of times,
Yes.
and a lot of people used to test mediation through this approach.
Yeah.
But the latest literature says that you should not, or you cannot, you should avoid Barron and Kenny's approach
Yeah.
to check the mediation,
Yes.
because it has certain limitation. There was another test, Sobel test was used previously, but that's outdated as well. So current approach is we Preacher and Hayes, they have done a lot of work on this
Very.
conditional process and mediation. So
Yes.
according to the latest literature, we can test the mediation through indirect effect, right?
Yes.
If you see B and K, for B and K, you need to have three hypotheses to
Yeah.
check the mediation.
Yes. The three assumptions.
IV, IV significantly affect DV,
Yeah.
IV significantly affect mediator,
Yes.
mediator significantly affect DV. So B and K approach have three steps. So you
Yeah.
need to have three hypotheses to check mediation, but that does not exist anymore. Don't need to check three hypotheses for mediation. You can simply
Check one
check
hypothesis.
through, yeah, indirect effect. Yeah.
Yes.
So
True.
that's the latest. We can check through bootstrapping, right?
Yeah.
We can check through bootstrap. We'll be doing that. Uh, so when we
And
run bootstrapping, we see different results, and in result we have a specific indirect effect
mention
option. When
only.
you click on that option, it will give you the results of mediation, right?
Hmm. And Dr. Shah, we were very tired of this Boren and Kenny approach when I was doing my MS. I thanked the preacher and Hayes for coming up with the easy approach and the good one with the reasonable justification. And then I did my PhD with this justification of preacher and Hayes. Okay,
Yeah.
please continue.
There's a common misconception. Not
Yeah,
every third variable between the two variables means a mediator. You have to have a strong
rationale.
theoretical conceptual support for a mediation. Otherwise,
Yes,
you cannot
yeah.
justify it. You
Very rightly
cannot.
said. Very rightly said. A lot of students they do by their own, and they think it is their choice to place any variable in between the two variable, and they say it's a mediator. So they need to
No.
have proper theoretical justification for everything. Yes,
For
very right.
example, you can see two models X, M, and Y, X, M, and
Yeah.
Y, right? The
Yes.
first model is not a mediation,
Yes.
right? Because unless you have a justification of inclusion of M between X and Y, it is
Yeah.
not a mediator. It
Yes.
can be a stepwise model where
Yeah.
one variable is, if X is affecting M, then
Yeah.
M is affecting Y. So it
Yes.
can be a stepwise model. So
It
if you
can be a
want
mediator
M to
model.
be a, yeah, it can be a mediator only if you
Yes.
have a theoretical justification. If you have to
Yeah.
develop a hypothesis
Yes.
explicitly for mediator, only then you can have a mediation. Otherwise, it can be a simple stepwise model. So by
Yes.
looking at the model, we cannot say M is a mediator unless there's a theoretical justification of.
Justification. Yeah. And in research, we say we do everything with justification. We are not doing
Yeah.
anything for our own sweet will wish. We do everything just because it is required and it is justified.
So if you don't have any justification or something, don't uh,
Drag
include that.
yourself in that. Yes, true.
That's too difficult. So
Yes.
what we'll be doing is you can see the interface of this. Okay. When you open the Smart PLS, this is the interface will come up, right?
Mm.
So the first step is we need to create a project.
Yeah. Dr. Shahab, can we start in the next session? Then we will have continuous 40 minutes at stretch.
Yeah, that's fine.
That's fine. Okay, all the participants, please log in again so that we have uninterrupted session for 40 next minutes. right? Please join with the same login and ID. Thank you.